Hey there, my name is Rohit Kumar, and today we are going to discuss another very interesting research domain, which is embedded system. So when we discuss the concept of embedded system, then so many questions come to mind that what is the embedded system? What are the different sorts of components that constitute an embedded system? What is the sort of life cycle? What are the different types of embedded system? What are the different components or the how it is related to RTOS, real-time operating system, etc. So point is that embedded system and people do relate this term very much with microcontrollers. So let's see that what exactly embedded system is and how do we define different sorts of terms. Additionally, what are the different related key research domain, etc. in this particular domain. So when we say that embedded system is a very good field of research, so it comes because it's a part of computer system, means it's a type of computer system only. And it is said because it has a processor, it has some memory, it has some sort of input output mechanism, and in this way it becomes a complete computer system, though it is not as much powerful as a traditional, means as a normal computer system like your laptop or the desktop or kind of framework, etc. But when we have some particular system, then that particular system should be able to accept some sort of input, need to have some sort of processing, and then deliver the output in the desired format. Then we can say it's a computer. So embedded system performs means the things in this way, and that's why it has this sort of capability. Now point is that sometimes it has the sort of real-time constraints, and that's why you need to effectively or the very consciously use the different types of embedded system according to your application's goal. Because if you are going for digital signal processor, then digital signal processing related components and all those things means hardware support tools and as well as the microphone, etc., right kind of mechanism and the processing devices as well as the supporting chips you need to have on a particular embedded system. So in this way you need to design a specific type, means if you are a designer you can design, if you are just a user then you need to look for the suitable kind of need, and then you have to go for that particular specific type of embedded system. Now for example, the best example I can say that you can have a very general introduction in terms of Arduino and RPi. If you want to do only about basic kind of activity, means lighting up LEDs, some sort of signaling or sort of concept, then you go for the Arduino board. But if you want to do bit more complex task where you do need more memory, more better interface, etc. So sort of complete computer system look like environment, then you should go for RPi. So in this way, these two systems are means kind of example of embedded system where you can have that a chip or a sort of microcontroller is in use, and then you can use those microcontrollers according to your application need. Now when we say that embedded system is so good, then is the research is also good in this particular area? Yes, let me tell you that more than 130 countries authors have been continuously doing their research in this particular field, and more than 25,000 authors have been consistently exploring the various research topics in this domain. So when we say that these are the statistics, so many countries and the authors have been focusing on the development in the field of embedded system, then what are the possibilities for you? What are the current research trends? What are the key research topics where the focus is on? So let me tell you that whenever we go for these sort of hardware related details, then always first thing that comes into picture, that is computer architecture. So with respect to microcontroller, you can do the computer architecture related things or the sort of research, and then you can explore the new types of architectures. What are the shortcomings of the existing architectures? Then you can propose some novel architectures. Okay. Then the real test bed or the sort of microcontroller if you want to produce, means you want to work on the active deployment or the active development of the microcontrollers in this particular field, then you can work on that also. But for that you need to have some sort of hands-on experiment in this particular field, and you should go and have a handshake with some sort of a hardware company where you could have the sort of lab facility and you can go for that. Additionally, the operating system roles is very important in this sort of environment, and that's why the real-time operating systems come into picture when you want to deploy your embedded system in a practical environment, because usually embedded systems are used in some sort of practical environments where you do take inputs from user in real time and you are supposed to give the output with minimum delay. So when you have this sort of environment, the coding of your real-time operating system as well as its configuration becomes very important. Coming to the other side, that when we say that the memory and the resources are limited in embedded system, so the concept of ROM means read-only memory becomes important, because what is the pre-configured installation is there in ROM, that is very important to state the underlying or the basic functionality of the embedded system. And in this way, the ROM, as well as if you have the RAM, then what sort of RAM, what is the size of RAM, what are the levels, means L1, L2, cache, etc. If you do have, then very good. So in this way, you need to see the whole memory structure, the computing structure, and the sort of bus system, how efficiently, how fast they can communicate to each other. Again, lot of architecture related things. Okay. Now, when we say that all these things are there, so in total, we can say that in total, the computer engineering is there. So using the computer engineering concept, real-time operating system concept, the RPI and the Arduino related things, you can completely come into a space where you can say that there is a very much related term to this whole concept, that is cyber-physical system. Why I'm saying cyber-physical system? Because embedded systems are not able to store everything at their side. They don't have memory much, and they are constrained in many aspects. So that's why they need to continuously upload their data to some sort of server, and that's why we need to have help from some sort of fog computing, edge computing, or sort of cloud computing. So that's why the cyber physical systems becomes the reality, because the physical layer is being constituted by your embedded system or the sort of basic sensors. Means like in IoT video also, I have discussed this concept very well, that you have the IoT sensors at the physical layer. So similar way here, you have the embedded systems at the physical layer. And then, because when we say sensor and embedded system, then people do get confused that both are similar things. No, in embedded system, you may have lots of multiple sensors. But nowadays, sensor nodes are also coming in the form of modes, and that's why they are becoming powerful day by day. So you can say that many devices fall in the category of both domain. They are kind of embedded system as well as they fall in the category of IoT modes also. Okay, but basic concept is that physical layer constitute the devices, and the cyber layer constitute the all kind sort of computations which are happening in cyberspace. So cloud computing, fog computing, edge computing, sort of the cyber layer, and when you have the physical devices, those are the physical layer. Okay, now we are saying that these are sort of different things. Then computation becomes the main important thing, means where the computation is happening. Is it happening at edge level, is it happening at fog level, or is it happening at cloud level? So where the processing is happening, computation is happening, that becomes an important thing to discuss about, and that's why it's a very debated issue. Okay, you can go for research in this. Additionally, different sorts of structure, including the RAM, IBM, etc. You can go for the different sorts of architectural choice. Then you can discuss the concept of flash memory. You can discuss the different application level details, means what sort of application you are considering with respect to embedded system, like you are collecting data with respect to some field, or you are monitoring with respect to some security zone, or you are doing some sort of signal processing with respect to some set of patients, or etc. Okay. Additionally, you need some sort of runtime library so that you could have a support for your sort of ongoing functionalities. Then the multiprocessing, while multiple users, multiple processors, or the multiple embedded systems might be there. Then the concept of virtualization improves it to next level, because when you want to do processing at efficient level, the concept of virtualization comes into picture. And in my virtualization related video under my research topic and domain series, we have discussed about that how virtualization is improving the way of computation or processing, and how it can help you to maintain a sustainable growth in terms of computing. Okay, then you should always be worried about that what sort of execution time or the sort of computation time your device or the embedded system is taking, because ultimately delay is the thing that you want to minimize in any case. And especially in real-time operating system, if you don't want to, if you are not in a position to control your delay within the allowed limits, then there is no use of RTOS. Okay, then obviously you become kind of soft RTOS. Okay, so specifically if we say that if we are working with respect to hard real time operating system, so then it is very tough to maintain these sorts of delay constraints, and you need to be very specific about every sort of programming. But if you are working sort of soft real time operating system, bit leniency is there, but still not much. Okay, then the safety of the system is very important, because usually the embedded system are placed in open spaces, they are placed in fields, they are placed on roads, electric system, etc. So many open space embedded systems are put there, and they are supposed to perform the right kind of functionality. But being deployed in open space, there is access to the mischievous people, means the attackers are there. They may go have a sort of different configuration on your devices if allowed, or if they are familiar with the underlying architecture and sort of programming. And if they don't know this sort of thing, at least they can damage your device. And if the device get damaged, then your network may break. If network breaks, then all sort of functionality, whatever communication infrastructure you have set up, that is gone. So in this way, you have to be very much concerned about the security and the safety of your system. And that's why the safety of critical systems, especially in the domain of embedded system, becomes a very important topic of research. Okay, now coming to the life cycle of the embedded system design, because when you are saying that we are going to design an embedded system, relevant processes and its life cycle you need to have a look on, and then you can decide that where you can put your mind into, and you can contribute a little in the improvement of the life cycle. Then the participatory design, scheduling of the tasks, etc., and how to configure the embedded system, all these sort of things are very much related to the research domain of embedded system. So I think by now you must have got a basic idea that what sort of things are available, where you can go for and have a look down to for a specific interest research. Now, if we are saying so many things, then what are the sort of things that where you can get the funding? So many national, international bodies and the institutions are available for funding, specifically the defense forces, all sort of data collection agencies, and the monitoring services or the agencies may fund your projects. If you are not going for public partners, means for some government organization, etc., then you may go to some private partner and you can ask for the relevant requirements, and if they fund you, then you can continue your research. Though you are a fresh researcher, means we have started the series of research domain and topic specifically for the fresh graduates of research. So if they are they are starting their research, then they should have a familiarity that if they don't have the kind of research equipments or everything or the funding available at their side, still they can continue as an independent researcher. The all you need to do is maintain your priorities right, means you should always go for journals, not conferences, because you don't have fund at your side. Additionally, you should go for the reputed journals, means the SCI sort of and Q ranking based journals, and then you should always go for the sort of unpaid journals, because there are paid journals, there are open access journals, so all they need the money. So in this way, I'm going to just say all these sort of things, because as a fresh graduate, means as a starting graduate in PhD program or in research program, you need to understand these basics very well. Okay, now coming to that different sorts of things. So you may contact to the different ministries, even so many startup programs, and the relevant support is available under the state government as well as the central government's schemes, and you can go and have a check on all those sort of things. Now coming down to the concept of citations, then obviously the citations are on rise, because with the advent of IoT technology and its continuously rise, you are seeing that smart transportation, smart health supports infrastructure, smart cities, every sort of thing is going to be smart, and it is only possible with the help of embedded system, low power devices, and that's why the future is very bright. Okay, if you are interested in more detail about the sort of coming IoT technology, you may go and have a check on our IoT related video, and you'll get the relevant details. Now coming to some of the related journals, because I'm saying that you should go for journals and paid journals and the kind of related to embedded system, then I have some of the related journals for your reference, but there are many more. But some of them include the ACM transactions on embedded computing system, ACM SIG plan notice, and the microprocessor and microsystems, IEEE embedded system letters, electronics, ACM SIGBAT review, then ACM transactions on design automation of electronic systems, Journal of Systems Architecture, Journal of Circuit Systems and Computer, then the IEEE transactions on computer-aided design of integrated circuits and systems, and the International Journal of Distributed Sensor Network. In addition to these networks, there are many other journals, including the IEEE transactions on computers, IEEE transactions on very large scale integration system, means VLSI systems, ACM SIG ARC means the computer architecture news, then IEEE design and test, etc. And many more, means not only ACM, IEEE elsewhere. There are multiple like Tillon, Francis, Bailey, Hindawi, Oxford Press, then Springer, etc. So many publishers are there. So if you are not interested in one type of publisher, you may always switch on to the other and you have a look. Because many times it happens that you are unable to publish with one publisher due to some tough competition or sort of very less related journal in that publisher. So you should always go and have a check on other publishers. Okay. Now coming to some of the authors, means that if there are so many authors, then where to get the related authors, because it's always better to have the follow-up of the related domains authors. So you should always go to Google Scholar, have a check on your related domains authors, and there you may find many authors working in the field of embedded systems. But if I tell you, then Jabo Peng, Paul Pop, then Franco Fumi, then the Rolf Ernst, the Tomoyuki Ito, Yoon Jason Ju, and so many other authors are there. So most of these are being familiar in the domain of embedded system, and they are foreigner from Indian aspect, obviously. So you can go and have a check on Indian authors also. And specifically, if you want to say that where the embedded system research is going on, then most of the IITs and NITs are working, especially the IIS, ERs, IIITs, etc. Every top institute is working, who is in the domain of technology, is working on embedded system or IoT, because in any way it is related to almost multiple fields. Means with the smart transportation also you need to deploy sort of things, with the smart agriculture, with UAV system design also, with underwater sensor network also. Everywhere you can have the implementation or the use of embedded system. Okay, and the most biggest use case of embedded system is IoT. Okay, now coming to the different sorts of institutes, because we are saying that so many people are working, then which are the top universities, and we should know about it, because if you are going to have a better collaboration or the chances of recognition among the peer research community, then you should know about these sort of facts. Additionally, if you want to take admission into some sort of graduate program, you want to go abroad, or you want to explore the possibilities inside your country, then you should know about these sort of things. Then the University of California System, Chinese Academy of Sciences, University of California Irvine, then the French Institute for Research in Computer Science and Automation, University of California, Berkeley, then the Polytechnic University of Turin, then the University of Erlangen, Institute Mainz, then the Tsinghua University, Biang University, Technical University of Munich, etc. Okay. Additionally, in India, so different IIT site, you can go and have a check on the relevant researchers, and definitely you'll find many. Okay. Now coming to the sort of me, and one more detail I want to add, many times we do think that only the government institutions like IITs, NITs, those are the sort of good institutions. No, if you go to some very good private institutions or some state universities, like if you go to IIIT Hyderabad, if you go to IIIT Bangalore, if IIIT Delhi, then these sort of institutions, even many of the old state universities, they are doing very good level of research. Okay, so you can have a look at there also. And but always before going there, you need to see that what are the future aspects. You need to always discuss the things with the relevant people who are working in the similar fields in those universities, and then you should judge your decision. Okay. Now coming to the point that if everything is good, then what is the current status? Which are the topics which are under focus as of now, and which are the sort of things that you should go for as a researcher in embedded system field? And I am going to tell you some of the latestly published or latestly accepted articles for publication in some of the reputed journals. So first thing I'm going to discuss with you, in 2022, ACM transaction on embedded computing systems work is accepted, and its title is Cache Interference Aware Task Partitioning for Non-Preemptive Real-Time Multi-Core Systems. So here in this paper only you see that how many technologies they have discussed. First thing, cache inference awareness. Second thing is task partitioning. Third thing is non-preemptive means configuration. Fourth is real-time operating system related, and fourth is multi-core systems. So here you can see that in a single paper only you can have 4 to 5 different technologies and their good combo. Okay, so in this way you need to design your paper title as well as you need to focus your research at the common space of multiple domains. Okay, and in this way you have a chance of better publication. Then coming down here we have another journal whose name is ACM Transactions on Internet Technology. It is also accepted for publication in 2022. The name is Automated Security Assessment Framework for Wearable BLE enabled health monitoring devices. So here you can go for BLE technology, and you can go for wearable BLE. And here third thing is that automated means automation is in the picture. Fourth thing, that security is there, and fifth thing is assessment, because if security you have deployed many times, you don't need to assess it if you don't want to have the periodic kind of improvement in the system, but assessment is necessary for the periodic improvement in any sort of system. So in this way, again 3 to 4 technologies in a single paper. And if we go on to more things, then Bulletin of Electrical Engineering and Informatics accepted a paper in 2022. The name is Web and IoT based hospital location determination with criteria weight analysis. So a mathematical model based work. And then some water management framework for irrigation in agriculture is accepted for publication in 2022 under the environmental technology, etc. So you can see that multiple works are there. And if I tell you some more titles, then the thermomagnetic FEM simulation of PM synchronous motors with input data from telemetry device driving cycles, design of real-time monitoring of infant physical condition in sport training based embedded theory, then the energy consumption organization of processor scheduling for real-time embedded system under the constraint of sequential relationship and reliability, then the architecture of network on chip for secure data routing using 4H function of improved asset security algorithm. Okay, so in this way you can see that lot more works and the papers and the technologies are there where you can have a focus and you can explore your research interest. Now coming to that, is it the thing that you should focus on embedded system only? No, everything is supposed to be a part of interdisciplinary field, and nowadays means whenever some product comes into market, it is a part, means it is a result of interdisciplinary research. So there are multiple domains like the embedded computing, embedded systems, then the different sorts of engineering practices, internet technology, then the informatics, then you have the material sciences, material engineering, then you have the mobile computing, you have the wireless communication, and you have the real-time communication systems, etc. So many different domains are there, and all these domains are related to embedded system in some way. Okay, so explore your wings means explore your space. Just open your wings and then do all sort of research, all sort of mining that you can do at your side, and then decide and go for a better decision of research choice. Okay, thanks for watching this video. If you didn't like anything, please do criticize the video and comment down below. Please let me know how I can improve my videos further for analysis. Thanks for watching it again. Happy learning.